Hello, everybody. In today's lesson, we're going to finish up Module 10, and we're going to be working with generating equivalent expressions. We're on page 277 of the 6th grade Go Math textbook. So let's look at the Explore activity. So identifying equivalent expressions. One way to test whether two expressions might be equivalent is to evaluate them for the same value of the variable. All right, so for instance, if I said x is 1, well, 5 times 1 is 5. 5 plus 65 is 70. Well, if I put 1 here, right, that would be 14 times 5, which is 70. So we could see that these two are equal and so on. Okay, so basically what we have to do is just substitute a value for x to see if these two sides are equivalent to each other. So here they want us to evaluate each of these expressions for x equals 3. So substitute 3 for all the values of x. So here we have 5 times 3 plus 65. So order of operations tells us we do this first. So we get 15 plus 65, which equals 80. Okay. In this one, 3 plus 1. So it was x plus 1. We substituted 3 for the x. 3 plus 1, because it's in parentheses first, 4. So 5 times 4, we get 20. Here it was 1 plus 5x. We substituted 3 for the x, so we're going to multiply first. 5 times 3 is 15, plus 1 more is 16. All right, now we have to find the one that matches on the right-hand side. So again, this was 5x plus 1. So 5 times 3 is 15, plus 1 is 16. Okay, so those two are equal. 5 times 3 is 15, plus 5 is 20. So those two are equal. And 13 plus 3 is 16. 16 times 5 is 80. Okay, so which pairs of expressions have the same value for x equals 3? 5x plus 65 and 5 times the sum of 13 plus x. We have 5 times the sum of x and 1, which is equivalent to 5 times x plus 5. And our final one, 1 plus 5 times x, is the same as 5 times 13. I'm sorry, 1 plus 5x. 1 plus 5x plus 1, 5 times 3 plus 1. Okay. So those are equivalent pairs. How could we further test whether expressions in each pair are equivalent? Well, we could just try a different value for x. Because sometimes only certain values will work. Do you think the expressions in each pair are equivalent? Why or why not? Well, based on the one we tried, it appears that they are. Okay, how can we test? Well, let's put 5 in for each one. So 5 times 5 is 25. 25 plus 65 is 90. 13 plus 5 is 18. 18 times 5 is 90. If we put 5 in for here, 5 times 5 is 25. 25 plus 1 is 26. 5 times 5 is 25 plus 1 is 26. If we put 5 here, 5 plus 1 is 6. 6 times 5 is 30. 5 times 5 is 25 plus 5 is 30. So it appears that using different values of x, I still get those equivalent pairs. So it seems like they're the same value. Now let's look at 278. All right, so Lisa evaluated the expression 2x and x squared for x equals 2 and found that both expressions were equal to 4. Lisa concluded that 2x and x squared are equivalent expressions. How could you show Lisa that she is incorrect? Well, we could just try a different value for x. All right, such as, I don't know, x equals 3. So we do 2x and we do x squared over here. Substitute 3. We get 2 times 3, which is 6, and 3 squared, which is 9. So those two are not equivalent. Okay, so those two expressions are only equivalent for certain values. All right. Modeling equivalent expressions. We can use models to determine if two expressions are equivalent. So algebra tiles are one way to model expressions. And so if you don't have algebra tiles, we're just going to use a long rectangle for an x or a variable and a small square for values of 1. All right, so here, determine if the expression 3 times the sum of x plus 2 is equivalent to 3x plus 6. So here, how can we model 3 times x plus 2? Well, here we have x, and here's the 2. So x plus 2, x plus 2, x plus 2. In other words, we have 3 sets of x plus 2. Here we have 3 x's, so we write 3x, and we have 6, 2, 4, 6. All right, so the model for 3 times the sum of x and 2 has how many x tiles? 1, 2, 3. And how many 1 tiles? 1, 2, 3, 4, 5, 6. It has 6 1 tiles. The models for 3x plus 6 has 1, 2, 3 x tiles, and it has 1, 2, 3, 4, 5, 6 1 tiles. So is the expression 3 times the sum of x and 2 equivalent to 3x plus 6? Yes. Why? Because each expression is represented by 3 x tiles and 6 1 tiles. All right, number 2. Use algebra tiles to determine if 2 times the sum of x plus 3 is equivalent to 2x plus 3, and explain your answer. Okay, so we have 2 sets of x plus 3. X and then plus 3. All right, so that's one set of x plus 3. X, 1, 2, 3. X plus 3. And then we have another set of it. So we have second long rectangle, and then we have 3 small squares. All right, and then our other one is 2 x's plus 3. So are they equivalent? Well, here we have 6 1 tiles and 2 X tiles. Here we only have 3 1 tiles. So no, they are not equivalent. So they're not the same. The difference is in that 2 times the sum of x plus 3, there's going to be 2 sets of 3 or 6 1s. And in this one, 2x plus 3, there's only 3 1s. Okay, so they are not equivalent. Now let's go to page 279. All right, writing equivalent expressions using properties. All right, so this is a review of the different properties of addition, multiplication that we have learned over the years. So commutative property of addition. Recall that when adding, changing the order of the numbers does not change the sum. So 3 plus 4 is the same as 4 plus 3. Commutative property of multiplication was the same thing as this, except with multiplication. So when multiplying, changing the order of the numbers does not change the product. Here, 2 times 4 will give me the same product as 4 times 2. The associative property of addition, also known as the grouping property. So when adding more than 2 numbers, the grouping of the numbers does not change the sum. So here you'll notice that we have 3, 4, 5, 3, 4, 5. So the numbers are exactly the same order. The only difference is how they're grouped. Here we have 3 plus 4 grouped, and on this side we have 4 and 5 grouped. But you'll still get the same sum. This one would be 7 plus 5, which is 12. And on this side we have 9 plus 3, which is 12. Okay. And we also have the same property in multiplication. So when multiplying more than 2 numbers, the grouping of the numbers does not change the product. So here we have 2, 4, 3, 2, 4, 3. So on this side, they're grouping the 2 and 4. And on this side, they're grouping 4 and 3. 2 times 4 is 8. 8 times 3 is 24. Here, 4 times 3 is 12. 12 times 2 is 24. Distributive property. So you'll recall that multiplying a number by a sum or difference is the same as multiplying by each number in the sum or difference and then adding or subtracting. So multiplying a number by a sum is the same as multiplying each number in the sum and then adding or subtracting. So here, 6 times the sum of 2 plus 4 is the same as saying 6 times 2 plus 6 times 4. And the same thing for subtraction. 8 times 5 minus 8 times 3 is the same as 8 times the difference of 5 and 3. Identity property of addition simply says adding 0 to any number does not change its value. Identity property of multiplication says any multiplying a number by 1 does not change its value. All right, so keep those in mind. We're going to apply these properties to help solve and write equivalent expressions. So use a property to write an expression that is equivalent to x plus 3. Well, okay, so the operation is addition, right? So we can use the commutative property of addition to write an equivalent expression. Okay, so we could say x plus 3 is the same as 3 plus x. Okay, you want to use associative because we only have 2 terms. We want to use distributive property because there's no multiplication. So really, there's only one answer we could use here, is commutative properties. Some may have multiple properties you could use. Okay, so here we have A times B times C. Well, you see that A and B is grouped together, so we could use the associative property of multiplication. Okay, so the associative property of multiplication again says that when multiplying more than two numbers, the grouping of the numbers does not change the product. So here we have A times B, but I'd get the same product if I went A times B times C. Okay, so just how they're grouped. 3y plus 4y. Well, I could use the distributed property on this one. Okay. And I could say y times 3 plus 4 is the same as 3y plus 4y. Six plus n. Well, let's just use the commutative property of addition. And we'd have n plus 6. Okay. Could you have used the commutative property here? Yeah. We could have just said that 3y plus 4y is the same as 4y plus 3y. Okay. All right. Let's go to page 280. All right. So identifying equivalent expressions using properties. So use the properties of operations to determine if the expressions are equivalent. So we have 3 times the difference of x minus 2. And they want to know, is that the same as 3x minus 6? All right, well, 3x minus 2, what would that be if we use the distributive property? So it would be 3 times x minus 3 times 2. Well, okay, so 3x and then 3 times 2 is 6. So they are equivalent expressions. Okay. So remember, multiplying a number by the difference of two numbers is the same as multiplying each of the numbers and then subtracting. So 3 times x minus 3 times 2 gives us 3x minus 6. All right, in this one, we have 2 plus x times 1/2. And the other expression is 1/2 times the sum of 4 plus x. Well, again, we don't need to do anything to this. We can use the distributive property for this and take 1/2 of 4 times okay. So if we rewrote it using the distributive property, 1/2 times the sum of x plus 4 is the same as 1/2 times each of the numbers in the sum. So 1/2 times x plus 1/2 of 4 gives us 1/2 x plus 2. Okay. So is that the same as 2 plus x? No, they're not equivalent. 2 plus x is not the same as 2 plus half an x. Okay. All right, so number 6. Use properties of operations to determine if the properties are equivalent. So we have 6x minus 8, and we need to find out if 2 times the difference of 3x minus 5 is the same. So we're not. What is a common factor of 6x and minus 8? 6x minus 8. Or 2 times 3x minus 5. We can use either one. I'm going to go ahead and use the distributive property on this number here, or on this expression. So 2 times 3x minus 5 is the same as 2 times 3x minus 2 times 5. Okay, again, it's the same as multiplying 2 times each of the terms in the difference. So 2 times 3x minus 2 times 5. So 2 times 3 is 6x, right? 3x plus 3x is 6x minus 10. Well, the other expression is 6x minus 8. So no, they're not equivalent. All right, and in this one, we want to find out, is 2 minus 2 plus 5x the same as 5x? Well, we have multiplication, addition, and subtraction. Well, we can't multiply the x because I don't know the value of x is. But I can simplify 2 minus 2, right? 2 minus 2 is 0. So we have 0 plus 5x. Is that the same as 5x? Yeah, right? The identity property of addition says any number that you add 0 to does not change the value of that number. So 5x is 5x. All right, number 8. Jamal bought 2 packs of stickers and 8 individual stickers. Use X to represent the number of stickers in a pack of stickers and write an expression to represent the number of stickers Jamal bought. Is the expression equivalent to 2 times the sum of 4 and x? Check your answer with algebra tile models. All right, so he bought 2 packs of stickers and 8 individual stickers. Use X to represent the number of stickers in a pack of stickers. All right, so he bought 2 times X, because we don't know how many stickers were in the pack, and he bought 8 individual stickers. And we have to find out, is that the same as 2 times the sum of 4 plus x? Well, if we use fraction tiles, 2x plus 8 will be represented by 2 x's. Okay, so that's 2x plus 8. And now what is 2 sets of 4 plus x? So we'd have 4 ones plus an x. And then we'd have another set. Okay, so are they equivalent? 2x, 2x. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes, they're equivalent. Okay. So yes, because they're both 2x plus 8 and 2 times the sum of 4 and x are both represented by 2x tiles and 8 1 tiles. All right, let's look at page 281. All right, so how can we generate equivalent expressions? All right, so terms, the parts of the expression that are separated by addition or minus signs. All right, so 12 plus 3y plus 2 plus 4x plus 2y squared plus 4. Everything that's separated by addition symbol is a term. So in this one, there's 1, 2, 3, 4, 5 different terms. Coefficients, those are numbers that are multiplied by at least one variable. So 3 times y squared, 4 times x, 2 times y squared. Those are all coefficients. Like terms, those are terms with the same variable or variables raised to the same power or powers. So they're showing us that 3y squared and 2y squared are the same terms, and 12 and 4 are the same. Or like terms, sorry, not the same, but like terms. All right, so we can use properties to combine like terms in an expression. So let's look at 3x plus 2x plus 4. Well, 3x plus 2x, that's the same as x times the sum of 3 and 2 plus 4. Well, then 3 plus 2 is 5. 5 times x plus 4. So when we rewrite an expression without any parentheses, and so that all like terms are combined, we're doing what is known as simplifying the expression. All right, so let's look at some additional examples. Simplify each expression. 6x squared minus 4x squared. So we have a variable raised to the same power, so x squared, and then we have 6 minus 4. So 6x squared minus 4x squared is the same as 6 minus 4 times x squared. All right, and then 6 minus 4 is 2, so we have 2x squared. 3a plus 2 times b plus 5a. So 3a plus 2 times b plus 2 times 5a. 2 times 5a is 10a. So we can use the commutative property to switch places with the 10a and the 2b so that the 10a and the 3a are together. 3a plus 10a is the same as 3 plus 10 times a, which is 13a plus 2b. All right, and then y plus 11x plus 7y minus 7x. So the y's are like terms and the x's are like terms. So why don't we switch places with the 7x and the 7y, okay, using the commutative property of addition. So we have y plus 7y plus 11x minus 7x. Y plus 7y is the same as 1 plus 7 times y. Remember, there's a 1 in front of the y. Plus 11x minus 7x is the same as 11 minus 7 times x. So we'll wind up with 8y plus 4x. All right, so let's practice here. So number 9, we have 8y minus 3y. Well, that's the same as 8 minus 3 times y. 8 minus 3 is 5, so we're left with 5y. 6x squared plus 4 times the difference of x squared minus 2. So we have 6x squared, 4 times x squared, minus 4 times 1. So that leaves us 6x squared plus 4x squared minus 4. Okay, we have like terms, 6x squared. So that's the same as 6 plus 4 times x squared minus 4. So 6 plus 4 is 10x squared minus 4. (11) 4a to the fifth minus 2a to the fifth plus 4b plus b. So the b's are in common and the a to the fifths are in common. So we can rewrite 4a to the fifth minus 2a to the fifth as 4 minus 2 times a to the fifth. Okay, this is distributive property. Plus 4 plus 1 times b. 4b plus b is the same as 4 plus 1 times b. All right, so 4 minus 2 is 2a to the fifth plus 4 plus 1 is 5, so 5b. And our last one, we have 8m plus 14 minus 12 plus 4n. Well, the m and the n's are unlike terms, so we don't have to do anything with them. So we only have to combine the 14 and the 12. So we're going to have 8m plus 2, 14 minus 12 is 2, plus 4n. All right, let's work on the guided practice problems. Number 1. Evaluate each of the expressions in the list for y equals 5. Then draw lines to match the expressions in list A with their equivalent expressions in list B. All right, so we're going to substitute 5 for y. So that means 4 times 5, so that's 20 plus 4. 4 plus 20. 4 times 5 is 20, plus 4, so 24. Substitute 5 for y. 5 minus 1 is 4, so we get 4 times 4, 16. 4 times 5, which is 20, plus the extra 1, 21. All right, do the same thing for list B. Substitute 5 for 4, and we get 20 minus 4, which gives us 16. 5 plus 1 is 6, and 4 times 6 is 24. And 1 plus 4 times 5. 4 times 5 is 20, plus 1, 21. All right, so those two are equivalent. These two are equivalent, and these two are equivalent. So now, determine if the expressions are equivalent by comparing the models. All right, x plus 4. All right, we have 1 x tile, we have 4 1 tiles. Here we have 2 x tiles, and we have 4 1 tiles. So the 1 tiles are equal, right? We have 4 and 4, but here we have 2 x's, here we have 1. So no, they're not equivalent. All right, let's look at number 3. For each expression, use a property to write an equivalent expression. Tell which property you used. Well, this is A times B. Can't use distributive property. Can't use any of the properties of addition. I'm just going to use commutative property and say B times A. All right, and 5 times the difference of 3x minus 2 is the same as 5 times 3x minus 5 times 2. Okay, well, what property is that? That's the distributive property. Use the properties of operations to determine if each pair of expressions is equivalent. All right, so 1/2 times the difference of 4 and 2x is the same as 1/2 times 4 minus 1/2 times 2x. Well, half of 4 is 2. Half of 2 is 1. So 2 minus x. So number 5, they are not equivalent. Okay, this one has 2 x's. This one only has 1 x. All right, 1/2 of 6x minus 2 compared to 3 minus x. 1/2 times 6x times the difference of 6x and 2 is the same as saying 1/2 times each of the terms. Okay, so let's see what we get. Half of 6 is 3x minus half of 2 is 1. So those are not equivalent. 3x, it does not equal 1x. Simplify each expression. Okay, so 32 times y plus 12y is the same as 32 plus 12 times y. Okay, right? Distributive property. So 32 plus 12 is 44y. 12 plus 3x plus 12 minus x. Well, why don't we switch the order using commutative property so that the 12s are next to each other and the x's are next to each other. So rewrite it as 12 plus 12 plus 3x minus x. Okay, so we're using the commutative property to flip the order of the 3x and the 12. All right, so now 12 and 12 is 24, and 3x minus x, that's the same as x times 3 minus 1. So 24 plus 2x. Describe 2 ways to check whether algebraic expressions are equivalent. Okay, so we could substitute a value, right? Or we could use models. We could also use properties of operations to rewrite one or both of the expressions. So use models, the algebra tiles. Okay, so how could we check our work? Well, we could use models like this, okay, to compare them, or we can use order of operations like we've been doing here to check and rewrite the expressions. Okay, sorry, right up here. All right, so that's it for the guided practice. So we're going to take a break, and when we come back, we'll work with the independent practice problems. So until then, I'll see you soon.